Hello everyone. In the last video, we all did array implementation. So in this video, we'll be working on linked lists. The main difference between arrays and linked lists is that arrays are contiguous data structure, whereas linked lists they are not. Linked lists in memory are stored uh, at different places. It's not like they have to be contiguous. Also, if you see linked arrays have to be given a mandatory size while declaring them, right? We cannot declare an array without a size. It would simply give an error. So in linked list, we don't have any such issue. We can uh, add as many elements in the linked list and it would increase its size dynamically at the runtime. So we don't have to worry about the size in linked list. So this is the reason we use linked list over arrays. So what are all the operations that we are going to implement in linked list? Basically the same, the insertion operation and deletion operation. Insertion, the same operations that we did for array. Insertion at the beginning, at the end, and at a position. And same is for the deletion as well. Okay, so I mean, what's the difference between a linked list and array in actual? So let me give you one example. This is an example of a linked list. So here, uh, let me also add a class so that you guys can understand better. I'm making a class node which would have I'm considering each element of linked list as int and next. So this class represents each element of a linked list. This one, this two, three, four, all these are nodes of linked list. So this node has data 1 and next is the address of next node in the linked list. So the next of this node would contain the address of this node in the linked list, and this node would have data as 2 and next as the address of 3, right? And similarly this node would have data as 3 and next would be address of 4 node. This is basically a linked list. So whenever we need to add a new element in this, what we have to do, we just simply have to add a 5, a node having data 5 in the next of this node, and the next of this node would have null. This is basically a linked list, and the start of a linked list we represent as head. Head represents that okay, this is the starting point of our linked list, and head points at the very first element of the linked list. So this is our linked list, and let's implement it. So we have already created a node for our linked list. What our node would look like. Now let's also define a head. Initially head would be null, and head would be null, it means that it is not pointing to any element, any node. So it would simply mean that the linked list is empty. So initially our linked list is empty, so our node head would be null. Let's start with this. Okay, so let's create a method of inserting at the beginning. Insert at begin. What it would take? It would take the element which we need to insert. That's it. Uh, so, do we have any corner cases to check before inserting at the beginning? Yes. Uh, but before this, let me create a new constructor in this node. And that constructor would take data and so this dot data would be equals to data, and this dot next will be equal to next. So we will initialize these as soon as we create a new node. Okay, so let me create a new node. Let's name it new node only, and in the data we will insert element, and in the next simply null. So we have created a new node. Now let's suppose this is our array and we need to insert it in here in the beginning. We need to insert, let's suppose we have element 0, so we need to insert 0 in here. So what we have to do, we have to point head to 0 and we have to point 0 to 1, right? Also, what if our array is empty? If our array is empty, then our head is pointing to null. Then we would just have to point head to 0 and we are done. So the logic behind this is whatever heads next is pointing, heads next is pointing to the first element of the linked list. So our uh, the next node of the new node would point to the next of the head, and the head next will then point to our new node. This would be the logic, but if our head is null, we have to handle that condition separately. If our head is null, we would be having no null, or we would be having no next, right? So if our head equals to null, what we will simply do, we will simply write head equals to new node and return, right? Now what if our head is not null? If our head is not null, we will simply do new node dot next would be equals to head dot next, and head would be equal to new node. Okay, one thing I may have conveyed wrong. The head is the very first element itself. Head is pointing to the very first element itself. We don't have head as a element in linked list. Head is simply pointing to the first element. It is not a node. I mean, it is a node, but it is pointing to the very first node. So we don't need to put next. We are just uh, we are just at we are just pointing to the first element of the linked list. We are just naming it as head. We are just referring it to a new variable head. Okay, so head equals to new node. This is our insertion at the beginning. If there is only one element and like this all is not there and one is pointing to null and we want to insert 0, so what we have done, head was initially pointing to 1, it would be head. Okay, so yeah, so head was initially pointing to null, or 1 was initially pointing to null, right? It was, if it's a bit confusing to you guys, let me, so this was our array initially. Let me write it this way. Okay, our head 1 was initially pointing to null. Now we need to insert 0. So new node is assigned 0 and new node dot next equals to head. Head is 1, right? So now we have another element 0 which is pointing to 1, which is pointing to null. Okay, so we have got two lists here, but we need to link this head to this 0 so that we know now this is our new linked list. So we just point head equals to new node. So our head is pointed to 0 and we have got a result. This is insertion at the beginning. Now let's insert at end. The same new node equals to node element. I have not declared it. Let me declare it. So I've created a parameter element. Okay. So we have declared a new node and now we want to insert at the end. For this also we need to check if head is or equal to null or not. Just copy this. If head is null, we will simply insert it in the head. If head is not null, then we would have, if we have a linked list, like we have a long linked list, okay? Now we want to reach up till here at 3. We need to reach to the node which whose next is pointing to null, right? So we only have head as the information. It is the only information we have initially about the linked list. So we have to traverse from head up till the node which is pointing to null as the next. And once we reach here, we simply insert our new element in the next of this node. For example, if we need to insert 4, we will insert 4 at the end like this. So let's create the logic. So we need to traverse from head. So let me initialize a variable temp which is equal to head, and while we have to find a node which is whose next is null, while temp dot next not equal to null, we'll simply traverse ahead. Temp equals to temp dot next. As soon as we get an element whose next is null, what we will do, we will simply write temp dot next. Now temp dot next is not null, now we are assigning the new node in that temp dot next, which is new node, and then we are done. New node is already pointing to null. Okay, so this is insertion at end, very simple. Now what if we are given a position to insert into? So let's insert at a position. We would need two arguments here. One is the element and one is the position itself. Okay, so first thing what we need to check, if position is 1, the very first thing in each method is we are declaring the new node. Okay, so we have a new node ready. Now if we have to insert this new node in the first position, which is like inserting at the beginning, so even if it is empty, yes, so before the empty condition we have to check if position equals to 1. If position is first, then what we have to do, we simply write new node dot next equals to head. Even if head is null, we will get next is null. If it is not null, we will get the first element of the current linked list, and we will say head equals to new node. Done, and we will simply return from this method. Okay, so if this is the case when position is 1, now if position is not 1, then for example, if our linked list is empty, what we will do, if it is null, basically I think we don't need to check this uh, head condition now, because we are simply checking the position, because we will check if position is you will see. Let's first get the size of the, now when position equals to 1, we are inserting in this. Now see if, let's see if our linked list is empty or filled. How we can do that? By traversing each element of the linked list, we can find the size of the linked list, right? So for traversing, the same logic we used above. but with a little change. The condition in the while would be up till while temp not equal to null. We will also read the element whose uh, next is null. Let's declare one variable as size. Now size, well, while temp not equal to null, temp equals to temp dot next and size plus plus. Okay, so now if my size plus 1 is less than position, right? What this condition is, if the size of my current is 1 2 3 5, right, we get 5 in the size and the position we get is 6. So if 5 plus 1 is 6, we can insert at 6th position, right? But if we get 7, then this would mean our 6th position is empty. Then how can it be possible? After 5, we have to have something at the 6th position which will point to 7th position. So if that operation is uh, asked for, we'll simply print invalid insert position and return. Now this will handle our uh, empty case scenario also. If we don't have anything in the linked list and we have head as null, what will happen? If our head is null and position is 1, then this will handle it. If our head is null and position is greater than 1, then this will handle it. The size will remain 0 and yeah, and it will just simply print invalid insert operation. Also, if let me add one more condition here. If pause is less than 1, that is the invalid position. Right? We cannot insert in before the 0. So we'll just simply return. Okay. So a corner case checking is done. Yes. A corner cases are all checked. Now let's traverse through the loop. Uh, traverse through the loop, I mean traversing through the loop, reaching up till the position we need to insert. For example, we need to insert at third position. Let's say I need to insert at 3. So I will traverse up till a position one less than the position provided. I'll traverse one element up till one element back, and then once I reach here, what I will do, the new node next will point to the next of this node, which is 2, and the next of this node will point to new node. That will simply insert a new element in this linked list. So let's do this. Let's reuse a temp uh, let's give it a initial element as head, and let's use for loop for int I equals to 0, I less than position minus 2. Okay, r plus plus. Now what we'll do, temp equals to temp dot next. So we have traversed up till one element previous to the position we need to insert into. Now the new node next would be equal to the next of the previous element of the position we need to insert into, which is the element at the position itself. So let's insert it. New node dot next equals to temp dot next, and temp dot next equals to new node. That's it. This is our insertion at a position. Right? So we have written insert at begin, insert at end, insert at position. So we can also check this first before moving ahead to deletion. For that we will also need a print method. So let's write one. We are simply having to traverse it. Node temp equals to head, while temp not equal to null. What we'll do, we'll simply print the element, the data in that temp dot data, and say temp equals to temp dot next. Okay, so our print method is also there. Now let's check our methods. Let's create a object of our method of our class. Let's call ob.insert at begin. What I will need to insert 3, same as we did in the arrays. Three to insert in the begin, and then insert at end 4, 5. Okay, so we have inserted 5 elements. Let's insert at pause. Let's say 6, position 6, and just print. Let's so we don't get any error, and the expected output is 1 2 3 4 5 6. Let's run it. Okay, we get the output 1, 2, 3, 4, 5, 6. So this arrow is extra. Let's not worry about that. What I can do is, if that is bugging you out, okay. So this is our array, our uh, linked list. What if we insert to position 3? Let's check that as well. Okay, so I have changed the element, not the position. Position is 3, element is 6. Let's insert it. So it's inserted at third position and rest of the elements are shifted. So back. Okay, so all our methods are working fine. Now let's make delete methods. Private void delete at begin. So for deletion at beginning, what we have to do? Let me show you. We have this linked list. We want to delete something from the beginning. We just have to point our head to the next of this first element and we are done. As simple as that. And if our head is already null, we have our linked list as empty, then we just simply print empty linked list. If head equals to null, what we print? We print empty list and return. If our head is not null, what we do? Head equals to head dot next and we are done. Very simple. Now let's delete at end. So for deletion at end, let me first explain it. For deleting the last element of the linked list, first we need to traverse up till here, right? Not up till here, let's say up till here, up till 2. Sorry about that. So I'll traverse my linked list up till here. And what I will do, I will simply delete the next of this. How can I delete this? I'll simply point the next of this element as null and it would be deleted. As soon as I point 3 is next to null, 4 would be garbage collected or 4 will not be included in our linked list anymore, right? So, and why I said I'll traverse up till here, that you will understand when I'll implement it. Because if I travel up till here, if I travel up till here, no, I can travel up till here. I will just simply say 3 is next is null and we will be done. Okay. Yeah. So we'll traverse up till 3. And if the same condition, if our head is null, we'll simply return after printing empty linked list. Now let's traverse the array. While temp okay, so one more thing we need to check. For stopping at this position, the condition of while would be while temp dot next, which is this dot next, is null, right? While is not equal to null, we will traverse. But what if there is only one element? Then what if it is like this? Then temp dot next is null, and null, the next of null would give the error, right? So let's add a condition for that. If head dot next, there is only one element, head, and its if its next is null, equals to null, then we simply say head equals to null. There's only one element and we have deleted that. Now back to our logic, main logic. If temp dot next not equal to null, we will traverse. As soon as we reach one element previous to the last element, we simply point the next of that element as null. And we are done. This is delete at end. If you can imagine the linked list, that what is actually going on behind the scene, then these are very simple. These are the simplest data structure and most interesting one. I actually have a lot of fun while creating these. So we have deleted at the beginning, deleted from the end. Now let's delete from a given position. So private void delete at position. We will be given a position. Now for deleting from a position, we have to do some checks we did like we did in insertion. So the very first check would be the empty check, right? We cannot insert if, or we cannot delete if our linked list is empty at any case. So let's check, let's just copy it. If our head is null, we simply say empty linked list. And if our head is not null, then we first have to get the size of the linked list as we did in the insertion. So node temp equals to, we can create a method of it instead of writing it again and again, but let's write it as of now. We can just simply put this in a different method and use it which returns the size, and we can use it as many times as we want. But let's just use it for now. Okay, I have to create a new method. This will keep bugging me. Private void, not void, int get size of the linked list. So we'll simply return size. And here in the insertion, we can simply delete this and write int size equals to get size. Okay. Okay. So let's use this method here also. We have got the size of the linked list. Now we need to check that if this size is less than the position given. I mean, we have the linked list of size 4 and we are being asked to delete a element from positions 8 or 10 or 7. So we need to check if the size length of linked list is not less than the position given, right? So we add this condition if size is less than position given, then we simply says out invalid delete position, right? Now our position is right, everything is right, our uh, linked list is not empty. So now we need to traverse up till that position and delete that node. For that we have to use this next, right? So before that we need to check this as well. If we have only if I mean if position is, I think this will be handled by position if position is 1. Let's write if position is 1, then we simply say okay, so we have already handled the empty condition. Now we are not worried about it. We just know that a linked list has element, at least one element. So we have to write if position is 1, we have to write head equals to head dot next. This is the insertion in the beginning, and we also return from here. We also return from above. So we have inserted if the position is 1. Now if position is not 1, then we have to traverse, right? For traversing we have a temp node ready, and we write for int I equals to 0 up till I less than position minus we have to traverse up till position -2. I'll show you how. So if we are given to delete at position 3, right? So what we have to do to delete this position 3, if we are starting from 0, 0, 1, 2, we have to stop at 0, and we have to stop at 1 and point the next of this to 3. So position is 3, we have to stop at 3 minus 2, 1 and point to 3. Got it? So that's what we are doing here. I less than pos minus 2, I plus plus, and temp equals to temp dot next. Once we reach that position, what we do, we simply say temp dot next equals to temp dot next dot next, and we are done. One thing, what if we are given the last element to delete? If we are given to delete third element, if we are given to delete this element, okay, so the position is 2, 2 minus 2 is 0, we will stop at 0 and we will say 0 next equals to next of this, which is null. Okay, so all our conditions are satisfied, all our corner cases are satisfied. Let's check this. I will be using the same we did in here. Let's delete one from beginning, delete one from end, and delete something at position 2. So when we delete from this, 1 is deleted, 6 is deleted, now position 2 would be 3, so our output expected would be 2, 4, 5. Let's run this. So we have got the output as 2, 4, 5. So these are all the basic insertion and deletion operation in linked list. There are operations like reversing the linked list, and also we can traverse the linked list recursively. So in the next video we'll cover that. I think this has already been a very long video, so let's cover those topics in the next video. Till then, take care.